Hello everyone, welcome back to my channel Medical Research with Mohan. I am Dr. Mohan Raj Sharma and today's topic for discussion is the value of a p-value. This is one of the very interesting and sometimes difficult topic in medical research and statistics, and my job here today is to make this as simple as possible for you to understand the concept. These are the learning objectives. The first, I will help you understand the meaning, importance, interpretation, and limitations of p-value. And second, some controversies surrounding the p-value will also be discussed, like has its value been too exaggerated or has it fallen from grace? This is the fundamental principle of statistics. We accept that there is a chance that we come to the wrong conclusion. Let's begin with a practical example. We have a target population from where we want to do a study. We take two samples from here. We call that sample 1 and sample 2. And for the patients in sample 1, we give a treatment A. And for the people from sample 2, we give a novel treatment. We label that as treatment B. And at the end of the study, we do the comparison and we get the result. So that results is finally inferred to the population of interest where we want to generalize. But with what certainty we generalize our result to the population is the concern for us. There are two approaches as to how you handle that situation. First is by hypothesis testing, and second by using confidence interval. So let's go to the hypothesis testing. What is a hypothesis? A hypothesis is a specific, clear, and testable proposition about the possible outcome of a scientific study. And this is usually starts with two possibilities. There is or there is not a difference between two populations. Now we use data from the sample we draw from the target population to choose between these two possibilities regarding the population of interest. And this is what is called hypothesis testing. Now let's get this same flow diagram here. So two competing possibilities are like this. Possibility one is there is no difference between two populations in the outcome of interest. This is usually designated as null hypothesis and written as S naught. In possibility two, a difference exists between the two populations in the outcome of interest, and it is written as HA or S1, and it is an alternate hypothesis. As a researcher, our job is to reject the null hypothesis. Now we need to quantify whether the difference you observe in your sample is genuine or by random chance. And this is where our hero enters, the p-value. Let's go to the steps of hypothesis testing. First, you always start with assuming that the null hypothesis is true. There is no difference between treatment A and treatment B. Then we feed the data to the computer in the software. And then third step is we apply the statistical test. The choice of the test depends on the type of data you have. For example, if you have a normally distributed continuous numerical data, then you apply t-test. And if you have a categorical data, you apply chi-square test. So regardless of what type of statistical test you use, the ultimate output is the p-value. And based on the results of the p-value, you interpret your finding and write conclusion. Now, with this background on hypothesis testing and the rationale for using the p-value, let's describe what p-value is. It is an abbreviation of probability value. Regarding its importance, in 80% of the peer-reviewed journal, p-value is described. Also, it is essential while writing proposal for grants or for IRC approval, and while you write thesis as part of your master's degree or doctoral degree, you need to apply statistical test and generate p-value. So it is extremely essential for all of us to understand the concept behind p-value. This is how it is defined in simple form. It is nothing but a probability that the difference you observe is by chance. The p-value is expressed as numbers between 0 to 1. It is not important for us as clinicians to know how the p-value is derived. All we need to know is how to interpret the result. This is a straight line that runs from 0 to 1. This is the golden rule of p-value. The closer the p-value to 0, our confidence increases to state the fact that the difference is genuine and not by a random chance. So while we interpret the result, we need to see how close it is towards 0 to claim something as significant. But the $1,000,000 question is this: how close should it be before we are sufficiently confident? So if it is 0 0.8, it is very close to 1, and this means that 80 out of 100 times it could have happened by chance. Not good. How about this? 0 0.5. So 50 out of 50, it could be by chance, it could be by real effect of your test drug. Also not good. Then then a group of statisticians came together and made a decision that if we keep the this threshold at 0.05, we should consider this as significant. As in medical science, nothing is 100%. So this is the arbitrary cutoff point to say something as statistically significant. How about this? 0.01. This says that 1 in 100 times it could be due to random chance. 99 out of 100 times it is due to the real effect of our intervention. So this is called highly significant. Let's do a practical example. 200 patients in the neurosurgery OPD were seen by two surgeons for low back pain in 1 month. This is the scenario. And here is the data. The variable analyzed were the degree of accuracy in diagnosis in percentage, and another was the mean duration of consultation. Two surgeons were involved. Dr. AS saw 100 patients, and out of 100 patients, in 80 patients, he was able to make correct diagnosis. Whereas Dr. GS also saw 100 patients, and he was able to give correct diagnosis in 75% of the cases. In terms of mean duration of consultation, Dr. AS took on the average 20 minutes to see a patient, whereas Dr. GS could see the patient in 8 minutes. Just looking at the value, we cannot say with certainty whether Dr. GS sees the patient faster or Dr. AS is better in making accurate diagnosis. We need to quantify how confident we are about the difference. And then we need to invite our friend p-value to quantify this difference. To quantify the difference, as I said earlier, we need to state a null hypothesis. So in this situation, regarding the accurate diagnosis, this is how we write null hypothesis. There is no difference in the accuracy of diagnosis between two surgeons. Regarding the duration of consultation, the null hypothesis would be there is no difference in the duration of consultation between two neurosurgeons. Now let's get the statistical test and generate the p-value. These are all hypothetical data. Just for the sake of explanation, I have put the number. Regarding the accuracy of diagnosis, the p-value was 0.6. Hence, the conclusion is there is no difference between two surgeons regarding the accuracy of diagnosis. How about the duration of consultation? The p-value generated was 0.002. This means that Dr. GS sees the patient significantly faster than Dr. AS. Let's take another scenario. Let's analyze the salary of specialist doctors working at two private institutions and their degree of happiness. And this is the table. The variables are the mean salary and the degree of satisfaction of the doctors. Hospital A has 100 specialist doctors, hospital B has 110 specialist doctors, and this is the amount of salary and the percentage of happiness. Just looking at the number, we cannot say with certainty whether hospital B indeed pays more or whether the doctors working in hospital A are better satisfied. Let's apply the statistical test and generate p-value. Here is the result. So in both situations, the p-value is significant. That means that hospital B indeed pays better, and however, doctors working in hospital A, despite with low salary, are more satisfied. This suggests that there are other factors that are also active in giving you the satisfaction while you work in the hospital. So, by these two examples, we can conclude that when you have something and that is supported by a significant p-value, it lends credibility to your argument. However, there are certain caveats that we should remember. A small p-value doesn't say anything about the magnitude of the difference. All it says is how likely it is due to random chance. Number one. Number two, if p-value is not less than 0.05, it is not the end of the world. You can always provide explanation for this, and the information that you generated is still very useful for others to use. That drug A is not superior to drug B is still a very useful information for other people to know. One slide dedicated to the difference between clinical and statistical significance. Let's take this example of pharmaceutical develop a new drug to treat hypertension. We have two sample of population. In sample A was given the existing drug, whereas sample B was given novel drug. The patients were followed up for 1 month, and at the end of 1 month, and this is the result. The difference in reduction of the BP was 3 millimeter mercury. The new drug was able to decrease the blood pressure by more than 3 millimeter of mercury, and the p-value was 0.05, significant. But this is clinically just not meaningful. 3 millimeter mercury reduction is just not too good for us, and this is called p-hacking. Sometimes p-hacking is done to deliberately get a statistically significant result to your advantage. So to conclude today's video, understanding the concept of p-value is very important in academia, and the reporting of your result with a p-value lends credibility to your statement. However, one should interpret the p-value taking into account its limitation. I hope the information presented in this video is of help to you in your academic work. I hope to see you in next video. Bye.